Hi everybody, welcome to today's Saturday session with ExamRevision. So this video is for Leaving Cert higher level maths students, and today we're going to take a look at calculus, and in particular we're going to look at the rules for differentiation. Okay, so calculus is a huge section of paper 1. It's really important. You kind of can't avoid it in paper 1. It will come up in lots of different sections, and it is a huge section of the course. Okay, so today we're just going to focus on the rules, because you need to know these rules to be able to tackle the more challenging application questions as well. Okay, so what we're going to look at first, we're actually going to start with just the notation, just in case you are a little bit rusty on that or haven't seen it in a while. Then we're going to look at differentiating polynomials, okay, which is kind of your most basic rule for calculus. And then we're going to use that to be able to work with the product, the quotient, and the chain rules. And then we're going to go on and we're going to look at differentiating trig functions as well. So differentiating sine, cos, and tan. Okay, so we're not going to look at any applications of this today. Just very quickly, calculus, you can do loads of things with calculus. So calculus looks at the rate of change. So for example, it can be used to find the slope at a point of a curve. It can be used to calculate your acceleration velocity. So there's lots of application questions. Them questions tend to come up in section B of the paper, so your context and applications. These rules are needed to be able to answer those questions, and these rules can also come up in your calculus question that might come up in section A. So kind of your more straightforward questions where they're just testing, can you apply the rules to the question? So we're going to start with our notation, okay? At the start, this can seem very abstract, but really once you start using it, it becomes second nature. So there are two different sets of notation we can use for calculus. They both mean the same thing, okay? So say you are given a function f of x and you differentiate it. Okay, we'll come to what differentiating is. Okay, for now, just think of it as you're doing an operation to the function. When you differentiate it, you end up with the first derivative, which we call f dash x. Okay, then if you differentiate that again, we'll end up with the second derivative, and it's f double dash x. Okay, or if they call the function y. Okay, so if you have y is equal to 2x squared plus 4x plus 7, and you differentiate that, you'll get your first derivative again, and that will be called dy dx. If you differentiate it again, you'll get d squared y dx squared. Okay, people find that a little hard to remember at the start, the d squared y dx squared, so write it down a couple of times, you'll get used to it very quickly. Okay, these both mean the same thing. Depending on how complicated the question is, sometimes I'll just use one rather than the other, but you can switch between them. So f of x goes to f dash x when we differentiate it, and y goes to dy over dx when we differentiate it. Okay, but the rules are going to be the same. We're just going to see this notation written down throughout the rest of this video. Okay, now we're going to get straight into it, and we're going to go into differentiating polynomials. Okay, so say if I have this, here we have our f of x equal to 3x to the power of 4 plus 7x cubed minus 9x squared plus 3x minus 10. And I want to differentiate it, okay? I know when I differentiate f of x, I can write it as f dash x. Okay, now that rule I've highlighted in yellow is kind of the key rule for this section. So we're going to multiply the number in front of the x by the power and then reduce the power by 1. Okay, so that's our basic rule for differentiating. Okay, probably the one we're going to see the most often. So multiply the number in front of the x. Okay, so I'm going to focus on this 3x to the power of 4 here. I'm going to multiply the number in front of the x by the power. So our power is 4. So I'm going to multiply 3 by 4. That's going to give me 12. And then I'm going to reduce the power by 1. So instead of x to the power of 4, it's going to be x to the power of 3. Okay, I'm going to do the same thing now with the 7x cubed. So I'm going to multiply the 3 by the 7 to give me 21. And then I'm going to reduce the power by 1, which is going to give me x to the power of 2. Next one then, minus 9x squared. I want to differentiate it. So I'm going to multiply the minus 9 by 2. It's going to give me minus 18. X, and then I need to reduce the power by 1. So it was a 2. It's now a 1. You don't actually have to write in the 1. So we usually just write down x. There's no need for x to the power of 1. Now, for the next ones, okay, when I differentiate 3x, I'm just going to get 3. Okay, why does that happen? I'm just going to kind of do it as rough work over here. Okay, so 3 to the power of x is the same as 3 to the power of 1. Okay, differentiated, I'm going to multiply the power by the number, that's going to give me 3, and then I'll reduce the power by 1, which will give me 0. Now, anything to the power of 0 is 1, so that's really 3 multiplied by 1, which is just 3. Okay, but I think it's relatively easy to remember. A number with an x will just differentiate to become just the number. Okay, so if there's no power in the x, that's what will happen. And then a number on its own will just disappear when differentiated. Okay, that's a little bit of an oversimplification, but if you just learn that rule, you can't go wrong. So that minus 10 is just when you differentiate, that will just disappear. Okay, so that's our first one differentiated. Now the next one, they tell us that y is equal to 5x cubed plus 6x squared minus 7x plus 20. Now, this time they used y instead of f of x. We're going to do exactly the same thing. When we differentiate it, we'll just call it dy dx. Okay, exactly the same rules. So I'm going to do the first one and then I'm going to try and let you finish it off. So multiply the power by the number. So 5 multiplied by 3 is going to give me 15x. Reduce the power by 1, it'll be to the power of 2. Okay, when you try and finish it off, I'm going to give you a second to try and finish it and then I will fill in the last 2 bits. Okay, so 6x squared, multiply the 6 by the 2, that's going to give me 12. Reduce the power by 1, that'll be x to the power of 1. You usually don't write to the power of 1, not technically wrong if you do. Okay, then minus 7x will just differentiate to minus 7. And then 20 is just gone. Okay, so they are our rules for polynomials. It's really, really important that you can do that quite quickly and accurately as well, okay? If you are rusty on that, I wouldn't go any further in the video. I'd make sure you know how to do that before we keep going. Okay, so that's differentiating polynomials. It does come up, okay, and we will see it coming up in the harder questions, but it can also come up in kind of that easier form as well. Okay, next thing is differentiating with the product rule. Okay, now I'm just going to give an example here. Okay, so the product rule. When do we use it? Okay, so this f of x down here, okay, I see I have 2 brackets being multiplied together. If we look at what we've done so far, okay, there was no brackets involved, nothing was being multiplied by anything else, it was just a straightforward polynomial, okay. Unfortunately, when things are being multiplied, so here, I can't just differentiate this as normal, okay. But lucky for us, we have a rule that allows us to differentiate when 2 brackets or 2 functions are being multiplied together, okay, and that is called the product rule, okay. So the product rule allows us to differentiate the functions that are being multiplied together, okay. This rule is given to you on page 25 of your formula book, okay. Now it's a little bit complicated, but once you see it done once, we should know where we're going from there, okay. So we're going to actually do the example and then we're going to work up to the rule, okay. So we're looking to find f dash x, and we're given that f of x is equal to x squared minus 4, all being multiplied by 3x cubed minus x squared plus 9. Okay, just my note I've written in there, there are 2 functions being multiplied together, so you must use the product rule to differentiate. Okay, you might remember from Junior Cert, if you want to find the product of 2 numbers, that's just them being multiplied together, which is where the name for product rule comes from. Okay, now, just for this, instead of writing f of x, I wrote y. Why did I change it? Just because up here there's a y. It's just easier to keep it all the same as the rule, but we know f of x is the same thing as writing y anyway from our studies of functions. Okay, now in our product rule here, our product rule says that y is equal to u multiplied by v. So I'm going to take this first part here and I'm going to call it u. Okay, so just down here, my kind of rough work, but it's also going to give me my attempt marks. I'm going to write down that u is equal to x squared minus 4. Okay, my second part then, from the rule, they say it's u multiplied by v. So this second part here is my v. So v is equal to 3x cubed minus x squared plus 9. Now, what I need to do is I need to find every part of my formula. Okay, so if I want to find dy dx, which is what I'm looking for, I'm looking to find the differentiated equation. I can see that it's u, which we know is x squared minus 4, multiplied by dv dx, don't know what that is yet, and v multiplied by du dx. Okay, now I need to find that dv dx and that du dx. If I want to find the dv dx, what I need to do is I need to differentiate v. Okay, so if I have v and I differentiate, I'm going to get dv over dx. Now, this is no more complicated than what we did at the start, so you're just going to use your normal rules. So the rules for differentiating the polynomial, where you multiply the number in front by the power and reduce the power by 1. So we're going to multiply 3 by 3 to give me 9, and then we're going to reduce the power by 1, so it'll be 9x squared. And then when we differentiate the minus x squared, we can just write a 1 in there if it'll help us, minus 1x squared, so that'll be minus 2x to the power of 1, which we don't need to write, so it's just going to be minus 2x. That's our dv dx, we got it by differentiating. Now, in our formula we also need du dx, and we're going to get that by differentiating u. Okay, now, should be working ahead of me here and trying to differentiate what this will be, so this will just be 2x when you differentiate it. Okay, now if we go back up to our formula, we know what u is, we know what dv dx is, we know what v is, and we know what du dx is, so we can fill those into our formula and find our answer. Okay, so dy dx is going to equal, okay, so our first thing, it's u, so u is x squared minus 4, and we need to multiply that by dv dx. So that's going to be multiplied by 9x squared minus 2x. And then we plus, the next part then is going to be plus v. V is 3x cubed minus 1x squared plus 9. And from our formula, we need to multiply that by du dx. So du dx is 2x. Okay, now all that's left here, we're back to relatively straightforward algebra. It's quite long, but you're just multiplying out your brackets just to tidy it up a little bit. Okay, so I'm going to do x squared multiplied by 9x squared. That'll be 9x to the power 4. Remember, you add your powers. And then x squared multiplied by minus 2x cubed. Minus 4 by 9x squared, that's going to be minus 36x squared. Minus 4 multiplied by minus 2x, that'll be plus 8x. That's our first bracket done. And our second bracket then, we need to multiply everything by 2x, so that's a cubed, isn't it? So that will be plus 6x cubed minus 6x to the power 4 minus 2x cubed plus 18x. Okay, and now just tidy that up a bit. So we'll add the things with the same powers. So we have 9x to the power 4, and we also have a 6x to the power 4, so that's 15x to the power 4 minus 4x cubed minus 36x squared plus 26x when we add the 8x and the 18x. Okay, so dy dx is equal to 15x to the power 4 minus 4x cubed minus 36x squared plus 26x. I know the question said find f dash x, but we know f dash x is the same thing as dy dx. Okay, so that is our first example with the product rule. They are long, it's quite easy to make a little slip, so I would say take your time. And writing out this box that I'm marking off here is really, really important. Okay, so you need to keep your work nice and organised, or else you're not going to know what v is and dv dx, etc. Okay, so we're going to do one more example of that. Okay, so we're going to do f of x is equal to 3x plus 1 multiplied by 5x plus 2. Okay, so if you want to work ahead and see how you get on with this, in an exam, the first thing I would be writing down is that I'd write down this is the product rule. And I'd go straight and I'd write down my formula from my formula book. So dy dx is equal to u multiplied by dv dx plus v multiplied by du dx. Okay, just so you kind of have your, you know what you need to find. Okay, you would also potentially get 10 marks for recognizing that you need to use the product rule. Okay, so I'm going to write down that my u is the first part, so that's going to be 3x plus 1. And then I differentiate that to get my du dx, which is just going to be 3. My v is going to be 5x plus 2. And my dv dx is going to be 5. Okay, numbers are a little easier here. Just a little bit of a shorter question. So now we'll be able to find our dy dx. So dy dx is u, which is 3x plus 1, multiplied by dv dx, which is 5, plus v, which is 5x plus 2, multiplied by du dx, which is 3. Tidy this up a little bit, it'll be 15x plus 5, plus 15x plus 6. So we will get 30x plus 11 for my dy dx. Or if you want to call that your f dash x, it's 30x plus 11. Okay, dy dx, f dash x, both mean the same thing. Okay, so that's our product rule. No matter how hard the numbers get, like that first example we did was a bit more challenging. That's why we worked through it a bit slower. If you can do the simple ones, just make sure then when the questions get a little bit harder, you take your time, make sure you're not making little slips. So that is our product rule that is used when we are multiplying functions together. So when there's two brackets and they're being multiplied together. Now, we also have a rule for when we are differentiating and we have two functions or two things being divided by each other. Okay, so the quotient rule, again, it's on page 25 of your formula book and allows us to differentiate when there's one function being divided by another function. Okay, now this rule, we're going to set it up exactly the same way. So the good thing is if you know how to use the product rule, you actually know how to use the quotient rule as well. Okay, so we're going to do exactly the same thing. So we want to find f dash x. So it's 2x minus 3 divided by x squared minus 4. Okay, so they're being divided by each other. That is our cue to use the quotient rule. Okay, I'm going to call the top bit u and the bottom bit v. Okay, same as they did up here. Now we're going to set it up exactly the same way. So down here I'm going to write that u is equal to 2x minus 3. And that v is equal to x squared minus 4. Okay, now off you go. We need to find du dx. Differentiate that, you'll just get 2. And dv dx here, differentiate that, you'll just get 2x. Okay, hope you're seeing now the importance of just knowing those basic rules that we started with, because you need them throughout all the other rules. So now all that's left to do is fill that into the formula. Okay, it's a little bit more complicated than the product rule one. So we'll have dy dx is equal to v, which is x squared minus 4, multiplied by du dx, which is 2x minus 3. Sorry, wrong one. So we have du dx, which is just 2. And then minus, that minus sign there is very important, u, which is 2x minus 3, multiplied by dv dx, which is 2x. And then all of that is divided by v squared, so it's going to be x squared minus 4 all to be squared. Okay, now what we're going to do, we're going to tidy up the top. There's no need to tidy up the bottom. We're going to leave that alone. What you will find when you move into the exam questions, a lot of the time you'll be given a number to sub in for x anyway, or they might tell you what form they want it in. Okay, but we're just going to tidy up the top a little bit. So that'll be 2x squared minus 8. That'll be minus 4x squared. So when I multiply the 2x by 2x, I got 4x, and then by the minus sign, that's going to give me minus 4x squared. And then when I multiply the 2x by the minus 3, that's going to be minus 6x. And then by a minus sign, that'll be plus 6x. Okay, tidy up the top again. That'll be minus 2x squared plus 6x minus 8 divided by x squared minus 4 all to be squared. Okay, so that's my f dash x. Okay, so once you can use the product rule, you're also able to use the quotient rule, maybe just with a little bit more care, as I guess the formula is just a little bit more complicated. Okay, again, we're going to do another example of that. Okay, so if you want to pause the video and give it a go, I will just write up the rule for you. Okay, just if you don't have your formula book handy. So dy dx is equal to v by du dx minus u by dv dx all over v squared. Okay, so be careful that your u's and your v's look different. Okay, so maybe just practice putting a u or a tail on your u just to make sure they look different. You're going to be using those letters quite a lot in calculus. Okay, so first thing I'm going to write down that u is the top bit, so u is 3x plus 1. So that means du dx is equal to 3. Then I have that v is equal to 7x plus 2, which means dv dx is equal to 7. So now all that's left to do is fill it into my formula. So dy dx is equal to v, which is 7x plus 2, multiplied by 3, minus u, which is 3x plus 1, multiplied by dv dx, which is 7, all multiplied, or all divided by 7x plus 2 to be squared. Tidy up the top a little bit, we will get 21x plus 6. And then be careful here, 3x by 7 is 21, by the minus sign is minus 21x, and 7 by 1 is 7, by the minus sign is minus 7. All divided by, leave the bottom alone. Okay, 21x and minus 21x will cancel, so you're left with minus 1 all over 7x plus 2 to be squared. Okay, so that's our product rule and our quotient rule done. If you can do one of them, the other one kind of falls into place because it's the same notation. So your main challenge here, getting familiar with the notation, and then it's just applying it directly from your formula book. Okay, now we're going to do this next question, which is kind of combining what we've done so far. A lot of the challenge with this question is actually your organisation. Okay, so find f dash x when f of x is equal to 2x plus 5 multiplied by x minus 2 all over x plus 3. Okay, so this is a quotient rule question. Okay, because we have division involved. Okay, so I have my quotient rule written out here. I would always say to write down the formula that you are using. So you have your quotient rule. So u is the top bit. And v is the bottom. Now, I need to find du dx. If I want to differentiate that u, okay, that is actually two functions being multiplied by each other. Okay, so really to differentiate that, I need to use the product rule. But if I think about this, I'm going to end up using the product rule within the quotient rule. It's possible, it's fine, but there is something else that I could do. So this is actually a fairly straightforward multiplication. So I'm actually going to multiply that out. Okay, so what I'm going to do is instead of writing it as the brackets, I'm going to write it as, so 2x squared minus 2x, or sorry, minus 4x plus 5x minus 10. So I can say, for a second, that u is equal to 2x squared minus, or plus 1x minus 10. Okay, I haven't changed that u at all. All I've done is I've written it, I've multiplied it out, because now when I want to find du dx, I can just differentiate this as a straightforward polynomial. Okay, so it'll be 4x plus 1. Now, there is absolutely nothing wrong with using the chain rule to differentiate this. Okay, but, or sorry, not the chain rule, the product rule to differentiate that. But sometimes, just to make our lives a bit easier, that took me very little time to multiply out, and it meant that I wasn't using my product rule and my quotient rule in the same question. Okay, sometimes that won't be possible, but here, if you can make your life a bit easier, I would recommend doing that. Okay, just multiplying it out instead of using the product rule. Okay, then we know v is x plus 3, so v dx, nice and easy to differentiate, that's just going to be 1. Okay, and now we can fill it straight into our quotient rule, so dy dx is equal to v, which is x plus 3, multiplied by du dx, which is 4x plus 1, minus u, which is those two brackets. Actually, I don't have to write down the two brackets. I can write down what I have simplified it to. So 2x squared plus 1x minus 10, multiplied by dv dx, which is just 1, all divided by v squared, which is x plus 3 to be squared. Okay, and now we'll just tidy it up a little bit. So multiply out those two first brackets there. It's going to be 4x squared plus x plus 12x plus 3. It's going to be minus 2x squared minus 1x, and then be careful, minus by minus, give me plus 10. Divided by x plus 3 to be squared. Simplify it up a little bit more, that'll be 2x squared plus 12x, when you tidy up the x's, plus 13. Okay, so dy dx, or f dash x if you want to write it like that at the end. Okay, so just up there, that little trick where I kind of avoided using the product rule. You could have used the product rule on that u, you'd actually end up with exactly the same answer. It's just I can make u look a little bit nicer to avoid using the product rule there. Okay, so that's our product rule and our quotient rule. They're two of the main rules you are going to see. So what we're going to move on now, we're going to look at the chain rule, so the third rule. So the chain rule, okay, the chain rule is given to you in your formula book on the same page, page 25. Is it page 20? Yeah, page 25, your formula book. In reality, we don't use this. It actually confuses things, okay? So this is an example of a question where you have to use the chain rule, okay? So just what I've written there in the yellow. So this function has layers, okay? So anytime you see a power, but when the power is over a bracket, okay? We're also going to use the chain rule for trig functions, which we're going to come to at the end, okay? So this function has layers. We're going to work by differentiating each layer separately from right to left. Okay, so I've written down in pink there what I'm going to do. I'm just going to talk through it here on the left hand side. So the first thing I'm going to do is I'm going to differentiate the power, and I'm going to leave the inside bit alone. Okay, so dy dx is going to equal. So first I'm going to differentiate the power. Okay, so I'm kind of going to pretend that I'm differentiating. We're going to say 4x cubed. If I wanted to differentiate 4x cubed, multiply the number by the power, that would give me 12x, and then reduce the power by 1, that would be squared. Okay, I'm kind of going to do the same thing here. Okay, so I'm going to bring the 3 down in front, leave the 3x plus 1 alone, and reduce the power by 1. Okay, that's step 1, so I've worked with the power. So in my head, I'm saying bring the power down in front, leave the bracket alone, reduce the power by 1. That's step 1 done. A lot of people actually stop there, okay? Problem is you haven't differentiated the inside bit yet. So that's our second layer, so our inside layer. So now you need to differentiate 3x plus 1. If I differentiate 3x plus 1, I'll get 3. Okay, and what I can do now is I can multiply those two 3's together to give me 9 multiplied by 3x plus 1, all to be squared. Okay, I'm going to leave it there. You could obviously keep going with that, square out the bracket, and then multiply the 9 in. When you get to the exam paper questions, you will see there's usually no need for that because you might know what number x is, so you'll be able to sub it in, or you might be told to give it in a specific form. Okay, so chain rule, we don't really use it from the formula book, so I just say differentiate the power, leave the inside bit alone, and then differentiate the inside bit. Okay, we're going to go on, we're going to look at another example of that. Okay, so this top one here first. So y is equal to x squared plus 3x all to the power of 3. Now that is a chain rule question. So dy dx is equal to, okay, first thing, differentiate the power. So we're going to differentiate the outside layer, so the furthest thing out to the right hand side, we're going to differentiate that, so that's the power, but leave the inside bit alone. Okay, so we differentiated the power, now you need to differentiate the inside bit. Okay, so differentiate x squared plus 3x, so differentiate x squared, you're going to get 2x, and then differentiate 3x, you just get 3. Now, what I can actually do from there, I'm just going to tidy it up a little bit. I'm going to multiply the 3 into the brackets. I'm going to go multiply 3 by 2x. That is going to give me 6x. And then the 3 by 3, that's going to give me plus 9. All multiplied by x squared plus 3x to be squared. Okay, that 3 was kind of easy to multiply into that bracket. I'm not going to square out the other bracket or anything, but just to tidy it up a little bit. Okay, next example now, it looks a little bit harder. So there's one key bit of information that you need to know. Okay, so anytime you have a square root, and you would have seen this in your indices, your study of indices. So anytime you have a square root, that's the same thing as to the power of a half. So I'm not differentiating now, I'm just making it look a bit more manageable. X squared plus 5x minus 2 to the power of a half. Okay, I haven't changed it. Really all I've done is wrote down the question again, but I have made it into something I can differentiate. So we don't have a rule for differentiating a square root. Okay, but we do have a rule for differentiating a power. Okay, so I can change that square root into the power of a half. Okay, so instead of writing square root, I'm going to change it into the power of a half. This is now a chain rule question. So the first thing I'm going to do is I'm going to differentiate the power and leave the inside bit alone. Now be careful when you're differentiating the power. Up here when I differentiated the power became 2 because you reduced the power by 1. A half minus 1 is going to be minus a half. Okay, and then I need to differentiate the inside bit. So when I differentiate the inside bit, differentiate x squared, I get 2x. Differentiate 5x, I'm going to get plus 5. Okay, we can keep going with this. Just for practice, I am going to keep going with it. All we're doing now is simplifying it. So that's it differentiated. So really what I can do is I can make this into a fraction. So it's going to be half by x squared plus 5x minus 2 to the power of minus a half by 2x plus 5. Okay, so I just put that 2 underneath the line. What I can also do, and this is the rule of indices, if you have a negative power, just bring it underneath the line and it's positive. Okay, so that 1 will stay there. This, I can bring it underneath the line because it's the power of a minus a half. If I bring it underneath, it's going to be a positive a half. Okay, and no need to write the 1, so it's 2x plus 5 all over 2 multiplied by x squared plus 5x minus 2 to the power of a half. If you really want to keep going, then you could keep going these forever, but instead of writing to the power of a half, I can change that into a square root. So it's 2x plus 5 all over the square root of, so 2 times square root of x squared plus 5x minus 1. Okay, probably the most common question I get asked is when to stop. When you start doing the exam questions, and like when to stop simplifying, when you start to do the exam questions, you'll realize that's not as big a problem as you think it is. Okay, so keep going for as far as you can, but this is our differentiated equation after applying the chain rule. Okay, and the final thing we're going to do now is we are going to look at the chain rule but with trig functions. Okay, so with sine, cos, and tan. Okay, so trig functions, differentiating trig functions, these are the rules that are on page 25. Okay, we're not going to get to all of them today. What we're going to look at is the highlighted ones. Okay, so we're going to look at how to differentiate cos, sine, and tan. Okay, now there is a straightforward case. So say if I'm given f of x is equal to sine x, then f dash x, it's given to you directly in the formula book, is cos x. Okay, so I'm just using this rule here. F of x is sine x, differentiate it, you get cos x. Okay, we'll do another example. So say, for example, if I have f of x is equal to tan x. Okay, differentiated, f dash x is sec squared x. Now, you don't need to know a huge amount about that, other than that's what it differentiates to, but it's actually given to in your formula book. Okay, now that's nice and straightforward. Unfortunately, for higher level maths, things don't tend to stay that straightforward. Okay, so if we're given something like, I'm going to say f of x is equal to cos 2x. Okay, and I'm looking for f dash x. Now, in your formula book, you're shown how to differentiate if you're given cos x. Okay, but you're not shown how to differentiate if you're given cos 2x. Now, what we need to do is we need to apply the chain rule here again. So I have the steps written out. Sometimes you won't have all of these steps. So step 1, differentiate the power and write down the trig function and the angle. Okay, so this is my trig function. And this is my angle. Now, there is no power. Okay, so this example that I've done here, there's no power. So I can ignore that step. I'm going to move on to step 2. Step 2 then says differentiate the trig function using your formula book and leave the angle alone. So I'm going to differentiate cos to get minus sine and leave the angle alone. That's going to be 2x. Okay, so that's me following step 2. And then step 3 then, differentiate the angle. So if I differentiate the angle, my angle is 2x. If I differentiate 2x, I get 2. Okay, I can tidy that up a little bit. I can call that minus 2 sine 2x. Okay, I think students find this quite hard in general. I think the biggest mistake is forgetting to differentiate the angle. Okay, so people in general are okay, cos differentiates to minus sine, but then they forget to differentiate the angle. Okay, so you need to multiply then by the differentiated angle. And if you learn those 3 steps, we'll see one in a second now with a power as well. Okay, we're going to go do 3 examples of this. Okay, so my first example, we have f of x is equal to cos 4x, and we're looking to find f dash x. Okay, now for f dash x, I see I have a trig function here. I'm thinking, okay, cosine rule, I need to know my rules. Okay, or I need to know where to find my rules. My rules are on page 25 in my formula book. So first things first, I'm going to differentiate the cos, leave the angle alone, and then I'm going to differentiate the angle. So I'm just going to slide back here to find out when I differentiate cos, I get minus sine. Okay, the top one there that I've highlighted. So when I differentiate cos, I get minus sine. And I leave the angle alone. Step 2 then, differentiate the angles. Differentiate 4x, I'm going to get 4. Okay, so then multiply the minus 4 in, or the 4 in, so it's going to be minus 4 sine 4x. Okay, so the first part there that I did, this is the differentiated trig function. Okay, so differentiate the cos and I left the angle alone. And then the second bit, differentiate the angles, differentiate 4x, and you just get 4. Okay, then I just tidied this up. I can leave the brackets in if that helps you. But that is how we got that there. Okay, next question then. Okay, this is going to look a little bit more complicated, and we're going to end up using the 3 rules that I had on the last page. We see straight away here that I have a power. Okay, I really don't like where that power is, so I'm just going to rewrite the question, not differentiating. I'm just rewriting the question as tan 3x all to the power of 4. Okay, that's perfectly allowed. You actually really need to do that to answer this question. Okay, now I'm going to go back. This is when I have a power, so this is the first time that I'm using all 3 steps that I had back here. So my step 1, differentiate the power and write down the trig function and the angle. Okay, so I'm going to differentiate the power. So that's going to be 4 times, leave the trig function and the angle alone, but I'm just working with the power. Okay, so it's 4 times tan of 3x all to the power of 3. Write that there. Okay, now what we need to do is we need to differentiate the tan. Okay, so we're going in layers. We've differentiated the power. Now we differentiate the trig function. So the trig function, tan differentiates to sec squared. Going to leave the angle alone. Okay, so I've dealt with the power, I've dealt with the trig function. Now I just need to differentiate the angle, which is going to give me 3. Okay, now multiply the 4 and 3 just to tidy it up a little bit. There's not much tidying up we can do here. So I can write that as 12 tan 3x to be cubed and sec squared 3x. Okay, no more tidying up we can do with that. So first, do the power, leave the trig and the angle alone. Then do the trig function, leave the angle alone, and then do the angle. So we're working in layers all the time. Okay, and the last one we're going to do here, we're going to do f of x is equal to the square root of sine x. Now, as we did in an example earlier, that square roots and calculus don't go very well together. So I'm going to get rid of that square root, but there's nothing I can do to get rid of it, but I can change it into the power of a half. Okay, so instead of writing the square root of sine x, I can just do it to the power of a half. Now I need to differentiate it. Okay, a lot of people might think that they've done a step of differentiation there and just make a little slip. I haven't done any differentiation. All I've done is some rearranging. Now, to differentiate, I see a power, I see a sine function. We're going to have to use the chain rule. Okay, so f dash x is equal to. So this is when we have our layers. So I'm going to try and do it without looking back. So first I have a power. Okay, so I'm going to go from work on the outside layer first. So I'm going to differentiate the power, but leave the inside bit alone. So I'm going to half, leave the sine and the x alone, and then reduce the power by 1. That's going to be to the power of minus a half. Okay, now what we're going to do is we are going to differentiate the sine. When you differentiate sine, now I will flick back here because I always double check these. No matter how familiar you get with them, it's always important to double check. Just because when you differentiate cos, it becomes minus sine. So that minus sign there is really important. But here I'm differentiating sine. When I differentiate sine, I get cos. So it's going to be cos x. Okay, and now my last step, that's when I differentiated the trig function. Now I need to differentiate the angle. So when I differentiate the angle, when I differentiate x, I just get 1. Okay, so that's a half sine x to the power of minus a half cos x. Okay, you can leave it there. We're going to tidy it up a little bit more because it's always good to practice our rearranging. So I can write that as, so I can put the 1 on top and the 2 on bottom, cos x. And then because this is sine x to the power of minus a half, I can bring that underneath the line and it'll be a positive half. Okay, I can then write that as cos x all over 2, and instead of writing to the power of a half, I can write that as the square root of sine x. Okay, so that may not look any simpler, but it is in its simplest form there. Okay, so they are examples with the chain rule and trig functions. Okay, as I said, the chain rule is given to you in your formula book. I think it's much easier if you just kind of talk yourself through it. So do the outside bit, do the power, leave the inside bit alone, then do the trig function, leave the angle alone, and then do the angle. Okay, that's how I would talk through it. The same, I'll just flick back here to the normal chain rule questions without the trig. Do the power, leave the inside bit alone, and then do the inside bit. Okay, so they are our main rules for calculus. Unfortunately, it's not all the rules. There are quite a few. There's also E and differentiating E and differentiating ln. But if you can use the rules we've done so far, they're quite similar and can involve the chain rule as well. Okay, so what did we do today? So we differentiated polynomials and we looked at our notation. Okay, so getting familiar with the notation, being able to switch between f of x and y and dy dx and f dash x. Okay, all very important. Then we looked at differentiating polynomials. You'll notice that that is used in every type of differentiation. No matter how hard things get, you need to be able to differentiate 3x to the power 4 really, really quickly. Okay, make sure you master that, or else everything else down the line will things won't fall into place. Okay, then we differentiated using the product, the quotient, and the chain rules. What's super important, you are able to pick out which rule to use. Okay, they are given to you. The product and quotient rule we use directly from our formula book. Chain rule, I wouldn't use the formula, just kind of talk yourself through it. Just know when to use each one. And then we looked at differentiating trig functions with our chain rule as well. Okay, so calculus, it's a huge section. This is, I guess, what you would do at the start of calculus, but it's really important that you don't get lost in the middle of calculus, okay? Because if you do, things down the line are going to get much harder, okay? So do a bit more practice at these. Make sure you're writing down all your steps and keep your work as organised as possible, especially when the questions get a bit longer, okay? Hope you found this video helpful, and check back in for more Saturday sessions for Leaving Cert Higher Level Maths.